All right, day 6 notes is basically solving exponential equations with and without logarithms. Before we get into that, we have to talk about two things. One, change of base formula, and how logarithms are the inverse operations of getting rid of bases and exponents, and vice versa. If I want to get rid of a log, I can use an exponent. So if I have, say, a to the x equals m, if I wanted to get x down, I could basically take the log of base a of both sides if I wanted to. And log base a of a to the x is just going to give me x, then this side would become log base a of m. Now, another way to look at it is if I had, say, log base a of, say, x, and I wanted to get x by itself here, yes, I could do a to the whatever gives you that, but I could also take a, raise it to the log base a of x, and that would just leave me with this a, wipes out that, and just leaves me with x. Those are a couple of things I want to say before we talk about the next part. Log base a of m equals, I'm going to say x. Now the change of base formula is, say you don't have a calculator and you're trying to figure out these logs. And the calculator feature only does log base 10 or natural log. What can I do then if it's not possible to do log base 5 of 89 on the calculator? Well, we know a to the x is equal to m. Now, one thing I can do is I could take the log of each side. Now, I'm not going to take the log base a. I'm just going to take log base 10 of both sides because our calculator can do log base 10. Well, if I have log of a to the x equals log of m, what I can now do is use that property with the exponents. I can bring that x down in front, and I would get x log a equals log m. Well, what would I have to do now to solve for x? To divide by log of a. And x would equal log of m divided by log of a. It's very hard to do some of these calculations without a calculator. Not all calculators can do base 2, 3, 4, 5, 6, 7. Most calculators can only do natural log or log base 10. So we say the change of base formula. If I'm trying to evaluate log base a of m, I could basically break it up into the log of m divided by the log of a. All right, so let's take a look here. What that means. Say I'm trying to figure out 5 to what power would give me 89. Not easy to do. So if I go ahead and I say, all right, I'm going to use change of base formula. Log of 89 over log of 5. Now I can go to my calculator and say, what is the log of 89, close parentheses, divided by log of 5. When I hit enter, this is what I get. I get 2.79. Well, this calculator could actually do the logs, so I'll double check that work. If I do the log base 5 of 89, what do I get? The same exact number. So this change of base formula is very important to know, not only for evaluating these, but at the same time for solving in the future. So the next one, if I wanted to find the decimal value of this, I would take the log of root 5 and divide it by the log of root 2. If I go to my handy dandy calculator, log of square root of 5, close the parentheses. That's the mistake you can make easily. So log of 5, close the parentheses, divided by log of square root of 2, arrow out, close parentheses, hit enter, and you should get 2.32. And the last one here would be log of 21 over log of 3. And when you simplify that, you should get 2.77. Okay? Now, solving exponential equations. Example 1 here is very similar to a problem you've done in the past, right? If I look at my bases here, both of these bases could be rewritten using the same base, meaning 9 could be rewritten as 3 squared, 27 can be rewritten as 3 to the third. Well, when I have 3 squared to the 2x, and then I have 3 to the third to the x minus 1, now I can raise these powers to a power. So 3 to the 4x equals 3 to the 3x minus 3. Now that I have the same bases, now I can take these and set them equal to each other. 4x equals 3x minus 3. Subtract 3x, x is equal to negative 3. But if I look at example 2, notice there's no way to write 4 and 11 using the same base. So how do I go about solving this? Well, there's 2 ways you could do it. The first method is I could get x down by taking the log base 4 of 4 to the x equals what I do to one side, I do to the other side. I would take log base 4 of 11. Now remember, when I take log base 4 of 4 to the x, these wipe each other out and just leave me with x. So now all I have to do is evaluate log of base 4 of 11, which I could do log of 11 over log of 4. And when I simplify that, I would get 1.73. That's one way to do it. Now, the other way to do it, which is the way I kind of prefer, is what I'm going to do is use that property of logarithms with the exponents. What I'm going to do is I'm going to take the log or natural log of the left side, then I'm going to take the log or natural log of the right side. So I basically have log of 4 to the x equals log of 11. Now I'm going to use that property where if this is an exponent, I can bring it down in front. Now what do I do to solve for x? All I do is divide by log of 4. So x equals log of 11 over log of 4, which gives me 1.73. Okay, example 3. I look at that and I say, no way they can be written using the same base. So all I'm going to do here is, again, take the log of both sides. Once I do that, I'm going to bring this exponent down. 9x times the log of 7 equals log of 15. But now I have to go through the process solving for x. First, I'm going to divide by log of 7. So I would get 9x equals log of 15 over log of 7, which gives me 9x equals, log of 15 divided by log of 7 gives me 1.39. And when I divide by 9, I would get x equals 0.1546, and I am done. Now, ultimately, anytime you look and you can get your bases written as the same base, you're better off using that, okay? So, when I look at this, first goal is to get this by itself. How do I do that? I subtract 8. So I get 6 to the 3x equals 36. Now, with that in mind, can these be written as the same base? And the answer to that is yes. So 6 to the 3x equals 6 to the second. Now, you can go through the other process. It's just that much more difficult. So now, all I have to do is find out what value of x makes these equal to each other, and I get 2/3. Example 5. Again, I'll show you could do it both ways. One, they could be written as the same base. So 2 to the x minus 5 equals 2 to the third. So x minus 5 is equal to 3. So x is equal to 8. But what if I use the logarithm here? Well, if I take the log of the left side, 2 to the x minus 5 equals log of 8. Now, x minus 5 comes down, all right, so it's x minus 5 times the log of 2 equals the log of 8. Now, x minus 5 equals log 8 divided by log 2. And if I go do the log of 8 divided by the log of 2, forgot to close the parentheses, log of 8 divided by log of 2. What do we get? We get 3. So 8x minus 5 equals 3. When you add 5 to both sides, x is equal to 8. So you could use both methods. One is just easier than the other. All right, go ahead.